All right, example 2 says the half-life of strontium-90 is 28 years, meaning that after 28 years, a given amount of the substance will have decayed to half of the original amount. Find the exponential decay model for strontium-90. All right, so we know we're looking at exponential decay, so we know our model, our general equation here, right? So let's go through our variables and let's see what we know. Do I know the ending amount? Nope. Okay, do I know the original amount, the starting amount? Nope. Do I know K? No. Do I know T?
This is going to be hard.
All right, I'm going to talk about how to fill some of these in just a minute. Do I know T? 28. All right. Now, I don't know the ending amount and I don't know the beginning amount, but I'm talking about half-life. So what do we know is going to happen in 28 years? Half of the original amount is going to be left, right? So let's let the original amount just stay the original amount. But we know that half of that is going to be my ending amount. So I can say 1/2 of that, of the original amount. I could pick numbers. I could pick like my original amount is 10, and that means that the ending amount would be 5, right? So you could put numbers in there if you needed to, but I'm going to stay with the variables. You're going to see something that's going to happen every single time we do this then. All right, so it looks like then what we're looking for is our K. So, and it told me to find the exponential decay model. So I know in the end I'm going to do like we did before, and we're going to plug it into the equation. So let's fill in what we know. So we know our ending amount, we said, is half of our initial amount. Equals that initial amount. E, we don't know K, but T is 28. So just like before, let's get that exponential part by itself. So how would I move that A sub 0? What's the mathematical operation between it and my part I circled, my exponential piece? Multiplication. So if I want to get rid of it, I do division. So no different than when we had an actual number there. You can. These are going to cancel, so you'll get your 1/2 every time. Equals, these are going to cancel, and so you get your E to the, and I'm going to rewrite that as 28K. And now everything's the same as what we did before. How am I going to get that K out of the exponent? Log both sides, and since I have an E, we're going to use natural log. So the natural log of 1/2 equals the natural log of E to the 28K. So let's move that 28K. So we got the natural log of 1/2 equals 28K natural log of E. And what is the natural log of E? It's 1. So we're going to divide by the 28. And so we have K is equal to the natural log of 1/2 divided by 28. So now we're ready to go to our calculators. And let's find approximately what K is. Alright, so we got approximately negative 0.025. Why is K negative on this one, but it wasn't on the previous one? Because what? I'm decaying, and so my K needs to be a negative number. If I'm growing, like the population was growing in example 1, then I need a positive K. But we're decaying here. It's getting smaller. It's the half-life. All right, so my equation then, remember, you're going to plug in everything except, excuse me, everything except T and A. So we've got A equals, but what was my initial amount? We don't know, did we? So we're going to go ahead and leave it this time as the initial amount there. E to the negative 0.025 T. All right, so for example 2 continued here. Now it says that we found the exponential decay model to be, that's all right, they changed theirs, they put negative 0.0248, okay? Which is the same thing as ours. Ours is just rounded a little bit more. So it says, if there were originally 60 grams, how long will it take for the strontium-90 to decay to a level of 10 grams? All right, since they gave us an equation, I'm going to go ahead and use theirs, but just know it's the same as ours. We just had a little more rounding going on. All right, so now what is that 60? Well, which one? A or A sub 0? It's the beginning amount, so it's A sub 0. Okay, so when A sub 0 is what, 60? How, I'm sorry? No, yeah. Ending amount is always what we're going to equal. So it's by itself. All right, so how long? That means we're looking for what?
Time.
We're looking for time. Bless you. Will it take for strontium-90 to decay to a level of 10 grams? So what is the 10? It's what we're going to decay to. So is it, what is that?
K.
It's not going to be the K because we already know K in this equation. We don't have an R. We only have one variable, guys, that's left unaccounted for. A, it's our ending amount, okay? We want to end with 10 grams. So let's plug it into the equation. So 10 equals 60 e to the negative 0.0248 t. And just like all the others, let's solve for t. So let's get the exponential part by itself. And so I could reduce that, but I'm just going to leave it as 10 over 60 right now. How do we get t out of the exponent? Log both sides. So I have an e, so we're going to use a natural log. And then move your exponent in front of its log. What is the natural log of e?
1.
Okay, so times 1, we don't have to write it. So divide by what's in front of the t. And we get t equals, or we probably should say is approximately. All right, so what did we get? All right, so it froze up here, and so to get to unfreeze, I ended up losing all my writing. But we were to the point we were going to say what t was anyways. So t was approximately what? 72.25. So the question is how long will it take for it to decay to a level of 10 grams? So in about 72 years. 60 grams of I don't even know how to pronounce that.
Strontium.
Thank you. I've been pronouncing it wrong. 90 will decay to a level of 10 grams, or will decay to, good thing I'm not writing straight, huh? 10 grams. Sorry, I just happened to look up there.